Hey guys, in this video I'm going to introduce to you the method of integration by parts and show you some examples of it as well. So integration by parts is the reverse of the product rule from derivatives, and the formula for it is the integral of u dv is equal to uv minus integral of v du. So u is a function of u of x. This is u. dv is variable dv. V is a function of v of x. Function of v of x. And du is variable du. So you generally use this when you cannot use u-substitution because the derivative is not necessarily there, or it's used kind of as an identity to solve for something like ln x. There is this very useful acronym, LIAT. It stands for logarithmic, and then is, it's inverse trig. A is algebraic function. And T would be for trigonometric functions. So how do you use this? You pick your u variable based on this. So if you need to pick your u, if you're given an integral and you need to pick your u, you pick it based off this. This is the highest priority. The lowest. And another trick is, whatever you pick for your u, what you want to get rid of a variable using u, because you're differentiating it so you can simplify it, if you know what I mean. So I'll show you. Okay, first example, ln x. So we have a logarithmic, but what else do we have? Well, we can imagine it that it's written like this: 1 times ln x dx. Right? So here's the thing. So our u, the highest priority, is logarithmic, so we're going to pick u to be ln x. And another reason why you don't want to pick v to be ln x is because it's actually v prime you're picking. This is v prime, so whatever you pick from here is v prime, so v prime will be equal to 1. And if you pick v prime to be ln, you'd just be left with your question, right? So now du, the 1 over x dx. And to get to v, you need to take the integral of 1, right? Integral of 1 dv. So it's just going to be x, right? We're going to just disregard the plus c. All right, now let's put it into our formula. So it's u times v. So ln x, let me do it nicely. Ln x dx is equal to u. So ln x times v, which is x, subtracting the integral of v, which is x, times du, which is 1 over x dx, right? Now we got to do this integral. So x over x dx, that's just 1, equals to x plus c, right? So that's just going to be ln x times x minus x. You could do plus c or minus c, it wouldn't matter. It's just a constant. Now this one. So we don't have exponential in here, right? But we have algebraic function x, so we're going to pick it to be that. And another way to think about it is, you want to get rid of x, right? Because if you get rid of x, the integral of e to the 6x is easy. Right? You just can't do it together. And you could technically, no, you can't. No, you'd have to use by parts for this one. Sorry to confuse you. Let's. All right. Actually, let me erase it so it's less distracting. Or, actually, no, sorry. Let me just copy it. Copy, and then we'll cut it so that we can put it back later. Alright, so u is equal to x, du is dx, and the integral of e to the 6x is very easy, right? E to the 6x, that will give you over 6, right? Let's put it into our formula. U, right, x times v, e to the 6x over 6 minus is equal to v, e to the 6x over 6. And look, you got rid of the x, so now you can easily take the integral of this, right? There we go. Okay. Now let's do these ones. Okay. Let's start with this one. This one could be a bit tricky. You can use substitution for this, but you're going to have to substitute it twice. So it's just not very practical. So we can just use by parts. We'll do u is equal to x, du is equal to dx, v prime root x plus 1, v equal to plus 1 dx. So we need to use u substitution for this. I'll write it out, but you can do it in your head easily. U is going to be a weird substitution. Yeah, let's just do u. Just remember this is a different u. I'll write it in a different color. X plus 1, d is going to be dx. So it's just going to be the integral of u to the 0.5, which is just going to be u to the 3 over 2 times 2 over 3 equal to 2 times x plus 1, 3 over 2 over 3. Right? So 2 over 3, x plus 1, 3 over 2. Right? Okay. Now let's put in our formula. It's u times v, x times 2 over 3 times x plus 1 with 3 over 2. Right? So let's move it over more. Okay. Minus the integral of, as we said, v du, 2 over 3 x plus 1, 3 over 2, and it's du. Du is just dx. We got rid of this variable right here, so we can just do the radical easily. Well, easily, it's messy, but we can still do it. So let's break it up again. I'll use this color. We'll put this outside. So now you just got x plus 1, 3 over 2. We're going to use u substitution. U is equal to x plus 1, du is equal to dx. And we use 3 over over 2, right? du. What does that give you? So you add 1, it's going to be u to the 5 over 2 divided by 5 over 2. It's going to be 2 over 5, right? Well, plus the c, but yeah, actually we need the plus c here anyways now. So now you just substitute back. 2 times x plus 1 to the 5 over 2 over 5. We had a 2 over 3 outside. Multiply it, which is going to give you 4 over 15 times x plus 1 to the 5 over 2 plus c. Right? Now let's rewrite it up here then. So 2 over 3 x times x plus 1 to the 3 over 2 minus 4 over 15 times x plus 1 5 over 2 plus c. A little trickier, but still doable. Okay, last one. Okay, this one. So, according to our thing here, according to Liat, we should be putting it at the trig function, right? Because the exponential isn't in here. So we'll do that. But you can already imagine that you're not going to go anywhere. The u is not going to resolve a variable, and the integral v du is not going to be any simpler, right? So you're just going to end up having, whenever you see something like this, you're going to end up taking a double integral by parts, right? Let me show you. U cos x du negative sin x, right? Dx. Now we have to put it, v is equal to e to dx, e to dx, right? Sorry, 1 second. Yeah. So now we put it into our formula, u times v. Is equal to cos x times e to the x, forgot the dx here, right? And then minus, now look at this, it's going to be v e to the x times negative sin x dx. So what do? We didn't really accomplish anything, right? Not really. But let's keep going. Why not, right? Let's do it twice. So we'll just forget about that. I'm going to do this in a different color. So now our new integral is e to the x. Let me distribute the negative so it's easier. Times sin x dx. Similarly, we have a trig function, so let's set u as that. Sin x du is going to be cos x dx. V prime is going to be e to the x, so then v is going to be e to the x as well. So uv is going to be sin x times e to the x minus the integral of du, which is cos x times cos x times v e to the x, and then the dx from the du. So look, we have this here again. That's the question. And we have a statement, no? We have an equation. So our equation is e to the x cos x dx is equal to cos x e to the x plus that, plus this entire thing. So now we can just isolate. So then we have, if we move it over, it's going to be 2 e to the x cos x dx is equal to cos x e to the x plus sine x e to the x. Get rid of the 2, divide it here, divide it here, right? And that will be your answer. So don't be afraid to do it twice. Don't be afraid to just pick any variable for u or dv or anything, because you're going to see if it doesn't work out, you're going to have to redo it. So in practice, don't worry about it. Just try and pick the best one and learn from your mistakes. But on a test, that's where the proficiency and the practice comes in to know which variable to pick for what. Have a great day.